Hello everyone. Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Azul Filawan, bonjour ou bonsoir tout le monde. Today we are sorry for the delay and welcome to our GDR online study jam online that we are going to discover together what is Kubernetes, what is Docker, and lot of stuff. So I will be with you, Aliane Abdenour, presenting GDGTZU for the next 3 hours. So in case you don't understand something, just hit me in the comments and we're gonna work together because that's our spirit. Sharing is caring, helping each other, and trying to understand everything. So, in case you have any question, I will go slowly. So, in case if you have any question, just ask it, and we are going to fix it together, inshallah. So, can we start? So, of course, this is a part of GDR Online, which uh, my colleagues are doing since last week, and it will continue to the next week. So what's the concept? The concept is to use quick labs and to show how to use them to learn a lot of stuff, lot of Google stuff. And at the end, it's wait. Let's see something. The link, we are going to share a link in the chat where you are going to activate a free month on Quick Labs, because Quick Labs is not free. You have to pay to use it. But because we try to share the knowledge for you as an exception, those days we are giving you 1 month for free. And if you complete a quest, you are going to have 2 months. I'm going to show you what is a quest, what is a lab. Don't worry, I'm here for that. But before, I need you to click on the link where you are going to use the free month. We are going to share it on the comments. So in case you don't have the free month, so please click on it. Once you click on the link shortener, which is a link that shorten another link, you are going to have something like this. You have to get the word Dubai in the keyword, in the link. Because once you have this, it's a campaign, which means that you are going to use a free month where you are going to practice anything you want from Quick Labs. But we advise you to follow with us. Once it's over, then you are free to go to the other courses. So I guess that everyone is here. I see that. Hi, Malak. So please, if you have any question, just ask me. You can stop me whenever you want. We are here to understand a lot of things because we are going to talk about Kubernetes, and Kubernetes, not only Kubernetes, but lot of stuff. So you are going to stay with me for the next 3 hours. It's gonna be a rush. We're gonna rock. We're gonna have a lot of stuff to learn together. So I'm here, you are here, let's do it. Before we start, let's do some theoretical stuff. Waiting for everybody to activate the free month. Let's do a free stuff. And of course, the slides will be available for everyone. You can read it, you can share it. So let's do it. Now, should we start? I see no comments other than Malak. Malak, hi. Do you hear us? So let's start. Today we are going to talk about Kubernetes, which is called to K8s. Don't worry, they are just names, but we are going to discover why it's called Kubernetes, why it has this kind of logo. Let's do it. Before we are going to talk about Kubernetes, what is cloud? Everybody is hearing about cloud. So we are going to explain what is the cloud. The cloud is not in the sky. I'm sorry for the presentation, it was in French, so I'm trying to adapt it to English because in the GDR, as you know, we are doing three kind of sessions. We are doing Arabic, we are doing French, and we are doing English. So any kind of language you want, we are here. So the cloud, it's not in the sky. When you upload your pictures, when you upload your documents on Google Drive, they don't go to the clouds. They go to servers. But why do we call them clouds? So let's, I guess that this course is from, in Algeria, we have something called Dirast al-Wasat, which is a module in primary school, and it's called دورة المياه في الطبيعة, the cycle of water in the nature. So do remember about this picture. This picture is going to show you what is cloud. We have the clouds here. Let's activate the pointer. We have the clouds here. And we have the particle of water. The particle of water, they are the data, which means that when we are going to upload our pictures or doing whatever data we are using, we are uploading it like particles of water. Then, once they get in the sky, the vaporization gets clouds. Those clouds are the server themselves. Now, what happens to the clouds? They move. And once they move, they don't have any limitation country, they don't have any limitation about borders, they just move. So when they move, it trains. So when we upload our pictures, they are on servers, they get replicated. We use the word replicate, and we will see that later. Once they get replicated, we're gonna get rain. And that rain, we have the same data. We are downloading here, and here we are uploading it. So the cloud, it's used to have more power and more security, which means that whatever it happens when you have your pictures, so there are some natural disasters. So in case you have those kind of disasters, we cannot stop them, but at least we can predict how to protect ourselves. So in case we have a disaster in, for example, La Qadar Allah in Algeria or whatever in the world, your data must be secure, which means that you have to get them. So that's the cloud. The cloud, it uses more power to get more powerful. It's like sharing something. Let's have a simple mathematical example. So for people who use Python or Java or what kind of programming language, they know what are the lists or arrays. So suppose we have 2, 3, 4, 8, 9, and we want to calculate the sum of the square of this, which means that we want to have 2 square, 3 square, plus 4 square, plus 8 square, plus 9 square, and then we make the sum. We can parallelize this operation, which means that we use 5 servers. The first server, we say, okay, first server, you calculate this. The second one, you take this. The third one, you take that, and so on. Once you finish, then we do the sum. We are doing this because we are splitting the time and we are gaining more time. The operation of doing this is called map reduce, which is the map is the square and reduce is the sum. We are doing a map and then we are doing a reduce. Map, you can parallelize it, but sadly reduce, you have to make it sequential. Sorry for my bad English. I try to mix between French and English. So when we have this, we are using what is called scale out, which means that in the past, we have one machine, one computer. So we have two choices. We have one choice is to change the RAM. We have 2 giga RAMs, and what we can do, we can change it to 8 giga RAMs or 16 giga RAMs. Or we have another solution, is to bring other small machines and send them those calculations. So when we bring those machines, we call it scale out, which is horizontal scale. And the old school, the old way where we are going to change our machine with another much more powerful machine, it's called scaling, which is the vertical scale. But in the cloud, we are using horizontal scale or scale out, which means that the more we need power, the more we add machines. Now, since we call the cloud, we need to know what is this architecture about cloud. The cloud, the base is what we're gonna find. We always find AAS, and then this letter will change. So the first layer, it's like layers, is the IaaS, which is infrastructure as a service. So when we buy an EIS on Google Cloud, for example, we are managing everything about our machine, which means that we decide which operating system, we decide something that we are in a low level. And then the simple example is the cloud, Google Cloud Platform, which we will see later. And then we have the PIS. The PIS is for, the P is for platform. Notice that it's this letter that change. So the platform as a service. The best example for this is the Google App Engine, which means that when you have an application and you want to upload it without you having a server in your house, what you are going to do, you are asking to Google to give you the operating system, but you don't have to touch it. What you have to touch is only your code. In EIS, you are asking Google to give you everything, but on PIS, you are asking Google to give you only what you are going to manage about your application, about your code. And you have the BIS. The BIS is the backend as a service. The best example is Firebase. So imagine you are developing Android application and you are hosting it on Google Play. And you need, of course, you need a database. So the best solution is to use Firebase, which means that you don't worry about the database code. You only code your Android application using Kotlin or using Java, and then you ask Firebase to do your requests in GET and POST and in like HTTP or in REST, and then it handles your database. You can check about this. It's out of our scope, but I just wanted to talk about it. And then we have the FAAS, which is a recent technology. The F is function as a service. So this concept is something related to the trigger. I give you an example. You have an application and then you want to upload pictures, and then in these pictures you want to create your social network. You want, when a user uploads a picture, you want to generate 3 versions of picture. The big picture on his profile, and then, for example, a small picture when he comments. So to do this, you just need to write a function and ask her, okay, every time you receive a picture or a file, make a trigger that will do the stuff we need to scale out or scale in or scale down our picture. And to use the FIS, you have to use Node.js. That's out of our scope. The best example for that is Google Cloud Functions. You can read about it. And then we have the SIS, which we are using right now. This presentation is using Google Slides. And Google Slides is a software as a service, which means that we are in a higher level. In the lower level, we have the infrastructure. And then we have the PIs. It's a platform. And now what we are using a software, which means that we can't change Google Docs code. It don't belong to us. What we want to do, we just want to use Google Docs. And that's called software as a service. And I can't imagine what we can have in future, which means that we always have a word as a service. Every day we have something new. It's future. So this slide is available in 2019. I don't know what happens in 2020. Now, as we talk about the virtualization, about the cloud, we need to know what is virtualization. And the best example, I guess that you have already used this, VirtualBox. In VirtualBox, when you use it, you can create a machine on a machine, which means that if you check here, I have CentOS, XP, and Lubuntu, which is LXD Ubuntu. I'm using that on a Windows 7 because I'm going to make a virtual system and not a physical system. But there is a problem, is that when I do the new and then type anything and then make next, if you check this, I'm using virtual resources, which means that if I want to virtualize this machine, I need 2 giga RAM. The 2 giga RAM are not directly to the hardware. I have to pass by Windows, which means this, which means, sorry, which means we have VirtualBox, we have VMware, and what we are using is called Type 2 hypervisor. The VirtualBox and VMware, they are called hypervisors. So here is the problem. We have the Type 2. We are here, we are using a laptop, we are on a hardware, we are using Windows 7, and then we have VirtualBox, and then we have, for example, Ubuntu. So Ubuntu will not have direct access to the hardware. It has to pass by the Windows 7, which causes problem. And this problem is power. We will not have a powerful machine. That's why there is the type 1. We have a type 2, and then we have the type 1. In a type 1, we have directly an hypervisor without passing by the OS. The OS himself is the hypervisor. So that's what we call the bare metal. From them, here are some examples. You have the VMware ES6, ES6e, you have Microsoft Hyper-V, Xen Server, which is open source, and then the type 2 that we have VMware, Player and Fusion, and we have VirtualBox. All of this, they are type 2, which means that we need an operating system, but those ones, they are used in production because we don't need to pass by another operating system. So when we use virtual machine, we need a vCPU, which is not a physical CPU. So the vCPU, approximately, we have 1 core. So for example, you buy a 60 core machine, you have, right now, we use 5, for example. If we have 8 cores, we can go until 40 cores, which is 5 multiplied by 8. Now, when we use the cloud, we need power. And from this power, we need, for example, a GPU. The GPU is used to make the work of the CPU slower, but in much more powerful way when it comes to parallelization, because that's a CUDA core, and that's a CPU core. So we are not interested about this because I wanted to talk about the TPU. The TPU is for Tensor Process Unit, which is used to make the machine learning. And I guess that you have already seen the tutorial and study jam about TensorFlow or about machine learning API. So, do you remember this word? Because it's the word that you are going to see in the next decade. It's called the DevOps. So in the past, you hear someone who says, okay, I'm a front end. Sometimes you hear someone who says, I'm a backend. And then sometimes you hear someone saying, hey, I'm a full stack. Now there is a DevOps. A DevOps is developer operation. So they try to break the gaps between the developers and the people that guarantees the quality of the software. And the DevOps, you always find the SRE. Now, SRE, since it's related to Google, if you make a search about SRE Google, you will have this, which is software which is seat reliability engineer. Look here, it's kind of layers, but if you check the bottom layers, it's the monitoring. The monitoring, you have to monitor everything. So we are going to see how to monitor this later. But if you see this, that philosophy is what makes a DevOps. So you can search about it on YouTube. I advise you to search about this video, which is really good video about what's the difference between DevOps and SRE. It's presented by Google workers, by Googlers, so you can have a lot of information about that. So let's go back to our slides. I hope you get something about what we are saying. Now, when we talk about SRE, we need to split our application in what is called microservices. The best example I give you, if you do, now imagine this website, imagine this page. As you know, this website is an HTML. And HTML, you have the HTML, you have the CSS, and you have the interaction, which is JavaScript. Now imagine that I give you all the source code in one file. And then I ask you, okay, can you change this color from orange to red? It would be really difficult because everything is one file. So why not split the three in three files? I give you an HTML alone, a CSS alone, and a JavaScript alone. And then when I ask you to go to the color and change it to red, it will be easier for you because you are going directly to CSS file. And that concept is what is called microservice. Microservice, we are going to split our application on small chunks of code, and then we are going to let them communicate between each other using REST, for example, REST or HTTP. And to do this concept, we use the CI and the CD, which is, let's give you an example before explaining what is those words. Do you know GitHub? Maybe I can find some answer about, I try to make some noise in the chat room. Can you hear me? Say something. Do you know what is GitHub? Well, I'm waiting. I give you 1 minute. I will use this minute to drink some water. No answer, which maybe I guess that you know what is GitHub. So before we see what is GitHub, there is the concept of Git and SVN. I give you an example. For example, we want to make, for example, we are using Photoshop, and then we are using a picture. The designer, what he do is to make a version 1, and then when he saves on a different file and he does version 2, and then he saves another file and he does version 3, and so on. So in case he wants to roll back to any kind of other version, he just check the date or the name of the version. That's exactly what is Git and what is SVN, which is version control. If we come here, Google is hosting his application as open source on GitHub. If you check here, you can find all the products. Check. You have 51 pages. Each page you have the product, the source code, the language, everything. If we come to TensorFlow, TensorFlow is on GitHub too. You can check the source code, you can check everything about it. You just come to github.com/TensorFlow. Same for Kubernetes, it's open source. And same for Docker. They are all open source. But to understand what is those two words, continuous integration and continuous delivery, let's check, for example, TensorFlow, or for example, Docker. If we come here and do /docker to bring us directly to the source code. Now, for example, there is someone who tried to delete a line and then another one who confirmed it. If you see this, we have all what was deleted in red and all what was added in green, which means that not only we will have different versions, but we can even check what happens in this new version. And that's called version controlling. So when we do the version controlling, we are doing a continuous integration and continuous delivery. The continuous integration, we are pulling our code to the code base, and continuous delivery, we are compiling our code, or we are doing it not to the production. Be careful, when we do CD, it's not 100% on production, because when we do a continuous delivery, we have what is called the deployment. And in our deployment, we have two types of deployment. You can check them on Google. You just do blue, green versus canary. So those two concepts are how we are using the deployment. There are many other ways. So we have a canary deployment and we have the blue-green. The blue-green, we do two servers, for example. The first one has a version, the second one has a version. Once we are satisfied, we are going to balance everyone to the other version. If there is a bug, we can go back to the first version. But the canary is like the blue-green, but we make, for example, 10%, 90% of people. So when someone comes, we send him here and we do a monitoring. We see if there are bugs, we see the feedback, and 90% we leave them on the old version. So in case everyone is satisfied, what we do, we take all of them and then make them to the new version, and then we will stop the old version. So the canary, we use just a small percent of people to test it, and the blue-green, we have to migrate everyone, and in case we have a bug, we can roll back to the new version, to the old version, sorry. So those are continuous integration and continuous delivery. But what comes, why we are talking about this if we are talking about Kubernetes? Well, what is this? Those are called containers. Now, the container itself is useless because we don't need the container itself. What we need is what is inside the container. And that's exactly what do Docker. Docker, we are doing our code base in one container, And then imagine that we need those 5 containers to have one product. Imagine we want to assemble a mobile phone. This container will have only screens. This container will have only batteries and so on. And then once we shipped it, we move the 5, and then we start doing what we want. We start to assemble our mobile phone. And if you see the fact that we split it on 5 chunks, we are doing a microservice. This is a service, 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 and we are making them communicate using REST. Because if we have a bug here, it will be easier to check about this one and the other one aren't working. And then to manage everything, we need Kubernetes. So the first thing is Docker. An example about Docker is to do what is called that doesn't work for me. So imagine I give you a software and then I don't give you a fully software. And then you need the DLLs, you need libraries. And then when you install it, I ask you now, you go to the internet and then you search for the DLL and you download it and then you install it, but I don't know where you are going to install it. But imagine that there is a way where I give you everything and then you just like compressing a file, a folder, and then compressing it, and then you just click and it runs. And that's what Docker do. I give you my application with the dependencies, with everything, and then I just give you the application and I tell you, okay, you just run Docker run, and you don't have to worry about the dependencies because everything is one file. So that's what do Docker. Because in the past, for example, as a teacher, sometimes when I need my students to use Ubuntu, and then sometimes they don't have access to internet. So what I do, I create a Ubuntu image, and then I do all the software inside it. And then what I do, I give them this image about Ubuntu. But why wasting 3 giga or 4 giga of space for just one library? Why not using a concept of Docker, or what is called in the past the Linux container, that you can Google LXC, and the LXC is an old way, which is what we know today about Docker. The LXC was a little bit difficult to implement, but with Docker, it made it easier. So why not give you something called a Docker, and then I tell you just run it, and it works. And to use Docker, you cannot use it anywhere. You have to use it on Linux, but on Windows, you need Windows 10 and plus. On Windows 7, not a chance. Now, here is a simple graph that explains what is Docker. If you see here, that's our old way. For example, my students want to install something, so I have to install it on VirtualBox, I have to install Ubuntu, and then that's really bad because they will use a lot of space, a lot of memory for nothing. But with Docker, we have the host OS, for example, Ubuntu, and then we have the Docker engine, and directly I give them the application plus the dependencies, which means that they don't need to go through another OS. Well, to install all those are just steps. UnionFS, which is a special way when it's like NTFS and EXT and so on. Those are a file system. Docker uses UFS, but we are not going to go deeper. So now all those steps are to install. We are going to share with you the slides, don't worry. But I have a problem. Imagine that as a microservice, I wanted to have, for example, 100 Dockers. Problem is that what if one of them failed? What if one of them don't work or don't start? How am I going to synchronize all of them? That's what Kubernetes do. I don't know if you already see this episode about Tommy Giri, and Tom was doing an orchestrating, and then all of them started failing one by one. So what was Tom doing? He was playing at their place, waiting for them to come back. And that's exactly what Kubernetes do. We have Kubernetes here. Sorry, let's activate the pointer. We have Kubernetes here. We have Docker 1, Docker, Docker, Docker. Everyone, every time some Docker fails, Kubernetes will handle how to, to repair this one. For the naming, we are going to see them later. For now, just remember, those are Dockers. I am Kubernetes, and I'm trying to manage them one by one. That's why we are calling this orchestrating with Kubernetes. And that's Kubernetes, and Kubernetes means El Captain. That's why we have this one. It's like a ship, because when we ship the containers, we need something that ships them, which is the captain. Ho ho ho. And and this is what makes Kubernetes. The concept is easy. We have a service, we have a volume, and then we have the pods. Later, we are going to see what is pod, what is a service, and how to handle all of this. That's our study job. And to control all of this, we need the YAML file. Welcome to the future. Old school, they use XML. XML is verbose. So if we need to say the person name, the age, which are his favorite sports, we need to do person, name. As you can see, it's verbose, and we are sending more data. We are doing a lot of strings. We are sending too many strings for nothing. And then there is the JSON. In the JSON, it's perfect when we use JavaScript, as it's just a simple object. So we converted this, and then Google said, okay, let's do a YAML, which uses indentation. So if you are a Pythoniast, if you come from Python, then this is heaven. You just leave the indentation and favorites. We have the put and the box. We know that they are under favorites. That's exactly the concept of Python. And all of this, as they are indented, they all belong to person. So when we do the configuration file about Kubernetes, we are using YAML. Now, let's do it. But first, I need to see some comments here, because, guys, you need to tell me what's going on. So, what's going on there? Hello, everyone. Are you there? So, I guess we will share now the link to the Kubernetes where you are going to practice, and then we are going to activate the free month. So, do you have the free month? Anyone there? Guys, it's a study jump, which means that we need interaction with you, because we need to hear what do you understand and so on. Anyone? Oh, sorry. I just refreshed on my phone and then I found that there were people who were commenting. I'm really sorry because, oh, wow, there were really comments. It seems that I'm like, I don't know what's going on. Yeah, I hear you. Yeah, hello world. Yeah, yeah, I'm sorry. I'm sorry because I got a little bit using uh, yeah, that's what we are doing. We are teaching you guys how to code. We are going step by step. It's just a small step. Yeah. And before I start, let me introduce you what is a GDG. So, do you hear me? Can you write GDG so I can see that you hear me and you are with me? Yeah, because I'm broadcasting using Wi-Fi and my phone is on 3G, so not that bad. Okay, thank you, hello world. That's the first thing we do in programmation. So the first step to do, as we are going to stream only for 3 hours, of course, there will be other sessions. I encourage you to come to Meetup here, meetup.com, and then type GDG. So here is the full link, meetup.com/pro/GDG. And what are the GDG? The GDG are Google Developer Groups. I'm one of them, which means that we are organizing events for the common community. Now, the question that costs $1 billion, how can we attend? It's easy. Just look how you can find us. You can find us wherever you want. We are everywhere. You just come to Meetup and check. For example, for myself, I'm from Algeria. Just check how many GDGs are there, and the number is still expanding, which means that even if you don't have a GDG near to you, you can ask to create a one and help people there. We are here to help. We are here to share the knowledge. So, in case you are around, just hit one of our GDG, come to us, it's for free. You just bring your laptop, and then there are many sessions. There are about cloud, there are about everything. And it's using the language you want. If you want Arabic, if you want French, if you want Amazigh, if you want any kind of language. So I repeat, here is the link, meetup.com/pro/GDG. And then you just click on, you just follow one of the GDG that is near to you. And then every time there is an event, you get notified, you attend, and step by step you will learn, and it's for free. So you are always welcome. Come and share with us the moment. So can we move? Yeah, I'm sorry, I'm reading the comments. It's yeah, I was going ahead and the phone was frozen. Today I'm just messy. So can we go ahead? Can we start our labs? Don't worry, we have enough time. Can you write something? Oh, perfect. Thank you. And sorry for the delay. Those left hand. I'm a left hand guy, so today I'm really messy. I don't know what's going on. It seems that it's not my day. So let's start about Kubernetes. So I guess we shared with you the comment. So you just scroll, you have the Quick Labs free access. You just click on it. Do you have, did you click on it? When you click on it, it will redirect you to this page and just do join. Or so when you do the join, if you don't have an account, it will create an account instantly If you have already an account, you just keep moving. And then there is one condition. If you don't have the free month, you have to guarantee after you created the account that you always have this string, which is 1s Dubai 2869. Do everyone is on this page? Amy, hello world, are you there? No, 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 no. You don't need to reactivate. Since you have the free month, don't worry. You directly start using it because you need to have the monthly subscription. I guess that now you know what is Quick Labs. Now let's talk about Quick Labs. Quick Labs is an e-learning platform, which means that you come here, you study. So if I do sign in with Google, so Quick Lab is just an e-learning platform. You come here, you learn, you have the labs. And every lab, you have the concept of quests. The quests is this one. You have the quest called Kubernetes in Google Cloud Platform. The quest has lot of labs, which means that if you finish all the labs, you are going to have a badge. And this badge, this is the badge that you are going to have. Why do you have to use this badge? Because it's simply, that's what it will be really useful for you. Because if I come here and well, I'm still on the free month. So if I come to my learning and then do view public profile, if you see those badges, you can insert them to LinkedIn. Every time you finish a quest, it gives you this badge. I repeat, you just need to come to my learning here. You click on the menu and then you do my learning. In my learning, you do view profile, view public profile. I guess it's not activated by default, so you have to activate it. Yeah, I finished 4 labs. Where can I find my quick labs profile link to send it? Yeah, that's how you are going to do. You click on my learning and then view profile, view public profile. And once you do a public profile, that's what you are going to pass on your Coursera month. This is what you are going to pass because this link is available for everyone. So when you do it on your resume, so everyone can come to your account and see what you know. So for example, you are sending your resume for a new brand that needs someone who knows how to use Kubernetes. So what you do, once you finish the quest about Kubernetes, you have this badge. So when he comes to your profile, he will be like, oh, so he knows how to use Kubernetes. I'm gonna hire him. See, that's the objective of, that's the reason why you have to do all the quests. Don't do it just for Coursera. That's good. You can get 1 free month, but the best thing is that once you finish all the labs on a quest, you get a special badge, and this special badge, it will be really useful for you. You just do add to LinkedIn and you add it to your LinkedIn, or you just use this on your QR code. You can generate, for example, a QR code and share this on your resume. So every time someone wants to hire you something about BigQuery for machine learning, that's fine. You will find that you know how to do it. So that's just a big opportunity. So don't use the free month on quick lab just to do one lab or two or four. Just try to do all of them. So let's go back to our course. Let's do it. Okay. Now, are you ready? We're gonna start. We have like 2 hours of code. I hope you learned something about what all I said on the slides, on GDG. I hope I was clear. Can we move? Perfect. Thank you, Amy. Thank you, Hello World. Let's do it. So, what we said about Docker, let's make it on practice. So, we need the first thing, as you know, we need always to open a private browsing. Why? Because to not mix between the Gmail account and the one that is created using Quick Labs, because Quick Labs, it's like a classroom. You have a classroom and you have a temporary ID. So every time you need to do a lab, you need a temporary access, which tells GCP, Google Cloud Platform, to give you the resources, the time of the lab, which means that if you have 1 hour of the, for example, if I come here, I have 1 hour to finish my lab. So in 1 hour, you have a 1 hour free access to GCP for free. So the GCP will send, the Quick Labs will send you directly to GCP. But as we are going to use a temporary account, we don't want to mix it with our Gmail account. That's why we need to open a private browser. So let's start it first here. We do start lab. And then once it generates the credentials we need to our lab, provisioning lab resources, I'm waiting. It takes time. Sorry, maybe it's my connection. Okay. Browse until here. All this to explain how to use Quick Labs. So I need you to come here. Hello world. Oh, we have hello world. Hey, hello world, your name is here. So I'm waiting to get provisioning lab resources. Yeah, we cannot, it's just advised to use the private browser. Why? Because if we don't do that, imagine that you already bought an account on GCP and you are paying for it. So in case we do this, you could use your own account. So which means that because it's pay as you go, this is the philosophy of cloud. You pay for what you go. So in case you are using your account, this could cost you money. That's why it's preferable, it's advised to use a private browsing where you are going to use only the temporary account and not your Google account. You can use another browser, but it's advised to use the same. If you are on Google Chrome, why not installing another browser if you are using a private browsing? Because you are not accessing to the cookie. It's a matter of cookie because this cookie is shared here, but when you do a private browser, your cookies are not the same, are reset. So we begin. We click first on open Google console. We wait. And that's why I told you to open a new incognito mode, because here, if we were using Gmail, we have to disconnect from our account. And when we disconnect, we could use all our service, Gmail and so on. We have to connect every time. That's why here, when he asks for our credentials, what we do, we just copy this link and paste it on the private browser. And here, even if I had Gmail, he will never show me Gmail. He doesn't know about my existence here. So what I do, I come here, sorry, and yeah, and then I copy this. If you check here, we don't have Gmail or Google. It's at quicklab.com. And you don't need to select everything. You just click on this icon and it will copy. We come here, we paste it as it is a Gmail account. We do next, and then we come back here, we copy the password. Don't worry about the password, it just generated temporarily. We do next, and we finished our process. Here you don't need to do update as this email is temporary. We just do done, and then we wait, and we have a free access to GCP, Google Cloud Platform. In other words, let me search something who uses GCP. Customers, if we come here, what I'm trying to say is that those brands, if they are using GCP, you have to know that their engineers see the same window as we are seeing right now. So you are doing something big. It's not anything. It's something really big. You see, those clients are using GCP, and the list is still expanding. So that's the future. If you know how to use GCP, you are guaranteeing your job. Once we are here, we just need to check this. I agree. You don't need to do I would like to receive and so on. You just need this. You choose the country. As I am in Algeria, I just choose Algeria, agree, and continue. Welcome to GCP. Here is the Alibaba treasure. So let's go back here, and here is our, what we are going to do. We are going to apply our instruction here and then apply them here. So the interface of GCP is divided on two. We have the product that we are going to use, and we have the Cloud Shell. The Cloud Shell is a fully working Debian machine. By default, it's Debian. So if we come here, we just click here to have much more space. We expand this, and of course, every time there is something, just tell me to stop. If you see here, I have Linux on my browser. And I do this when I teach students, because sometimes there are some students who will be like, no, my machine is too weak. I cannot run VirtualBox and so on. So what I do, they just open their browser. They have a free access, and we do everything about Linux. So if we do echo hello, it says hello. You can do everything you do on Debian or Ubuntu or Kali Linux. All of them are based on Debian. So you just come here and start doing your Linux job on your browser. So what we do, we just copy here and do our first Docker. Hello world. Your name is always there. Here is our first hello world from Docker. It doesn't do anything special. So we just ask them, okay, run the command which is called Docker. Run as an argument. We say, okay, Docker, run an application which is called hello world. Yeah, Yeah, you need to open the Cloud Shell because it's here. The Cloud Shell already have some tools that they are pre-installed, which are the Kubernetes, Docker, BigQuery, and GSUTL, which is the Google storage. All those you can find them on Google SDK. The Google SDK are pre-installed on your Cloud Shell. So you don't need to reinstall it on the Cloud Shell. So all the SDK is pre-installed on this virtual machine. Enchanté, Amy. So everyone has typed this command, docker hello world. Let me do something. Let's add something like, for example, word with two O's. If you see, it says repository does not exist, which means that we are not running the hello world locally. What we are doing is going somewhere and downloading the hello world, which we don't have right now with double O. So what you're gonna write here is not anything. You have to write the right word. So if you want, for example, CentOS, which we are, here is the magic. We are on Debian. If we run docker run CentOS, what happens now? It's gonna pull the CentOS image, and we are going to use CentOS on Debian without requiring any additional resources. We are here on CentOS because they share the same kernel. It's the Linux kernel, which means that any any Linux distribution you are there. If you use Docker, you can run another distribution without requiring other RAM. Remember, if we come here, sorry, if we come here and we see the architecture of Docker, here is what we are going to do. If we wanted to use CentOS and Ubuntu, here we have to install an hypervisor, which is VirtualBox. But as we are using Docker, they share the same kernel, so we don't need to reinstall another operating system. And that's the magic of the Docker. So let's go back to our lab. And we have here. So if we want to check which are our Docker image we have, we can do this. As you can see, if I zoom here, I have CentOS and I have Hello World because I already ran Docker run CentOS, but I don't have this hello double O word. Why? Because next time if I run CentOS, if you see, it doesn't need to download it again. It's already downloaded, so don't worry about it. So if I run again hello world, it will not download it from internet. It's already here. So to check what we have, we just use Docker image. Let's go back here, and if we run it again, it will not bring it from internet. Now, I guess you already know, if you are a Linux user, you already know what is PS. So if we do PS, is about the process. But if you use the PS with Docker, if you see here, we don't have anything because we are already outside the Docker. So if we want to check which Docker is running, because PS is which process is running on Linux. So you can, I think you know about this, everything full. That's the Linux way, because this writing is about BSD. for example, people from Mac or OpenBSD, but from Linux, PS is show me all process, everything and full, which means that it writes all what's happening on my machine. So if I wanted Docker, I just say Docker, show me which Docker are running. If I do this, there is no one. But if I add -a, I'm showing which Docker I already ran. So let's continue. And if you come here, there is, let me talk about this. So there are some labs when you practice your quick labs, there are some labs who don't have check my progress. Sometimes you find check my progress here. So let's go here. Don't worry, check my progress. But here it's only at the end. Sometimes you don't find this button. That's why you have to check here. And you will do run steps. As I didn't do anything right now, it will tell me 0 because I didn't do what is required from me to do, because there are some steps I have to pass through. So let's go back to our lab and let's build our first Docker. And I explain you why. Let's copy this, which means that make a directory called test and go to test. This double E means that if this fails, don't never ever go to the second one. And here, once we do it, we are just copying and pasting. And then I'm explaining you this. Here, we copy this and we are doing what is called the Docker file, because everything is called Docker file. So if we do ls, once you copy this, I repeat, you copy this and run it here. This is just redirections for people who come in from Linux. I'm redirecting the command cat to Docker file, and then I'm ending the file, and then I'm starting redirecting everything. So if I do ls, I find that I have a new file called Docker file. So what I do, if I do nano Docker file with capital D, I will find this. So let's explain what's going on this file. This is the file that makes you create your microservice. We were talking about microservice. So imagine that you want to give your small application or your chunk of your application to someone. What you do is creating a Docker file and tell the Docker file what he is going to do. So the first word, from, we are telling the Docker file to create an image from Node.js version 6. And which working directory? We are bringing the directory which is called app. And we are adding the local directory. And then we are exposing our application to port 18. That just, and if you see, it's well commented. Don't worry about this. To quit, just hit Control X. If you see here, this character is called control. Control X, and we are doing fine. Everyone is here? Can we move? Everyone created the Docker file. Perfect. Now, let's go back here. Here, we need to create now our Node.js application. We just copy and paste. Now, if I do ls, I have a new file which is called app.js. So if I do nano app.js, I have my first Node.js application. It's out of our scope, but what is the most important here is the port. We are making our application to the port 18. which means that if we change this port and make it to 1818, our Docker will not work. Why? Because in our Docker file, sorry, oh, sorry, what I just did? Okay, if I do ls, I'm sorry, and I do nano docker file, as you can see, we are exposing our application to port 18. So we have to respect this port. So we just created an application using Node.js and the Docker file. The Docker file, we are making it. Amy, you said no. What's going on? Ah, okay, perfect. So everything is fine. Perfect. Let's move. Now, we created the Docker file, we created our application. Now what we need to build our first application. Here is the syntax. We are saying, okay, Docker, now build our application that is called Node app, which has the version 0.1. And what will contain this? It will contain our current working directory, which is the dot. And what happens now if we validate? Docker will search first for the Docker file. Once he finds it, it enters inside and it will check what this needs, the dependencies. And from the dependencies, if you check here, he is downloading what it needs, which means he is downloading Node.js and all the stuff you need. And that's what you need. You just need one command to create a Docker file. You fill it about what you need. And once you do that, you tell him to build the application using your name. You can check, you can use any kind of name, but you need to give him the version. Now, what is the version? It's what we said about continuous delivery and continuous integration. This is the CI and CD. What we are doing now, we are using a continuous integration because we have the first version, which is the 0.1. Maybe later, if we change our source code, we need to name it Node App 0.2. So our engineer could know that we have changed our source code. Is it understood now? Everyone has compiled the application? Perfect. Now, let's go back to our tutorial. Now, if we do Docker image, as you can see now, we have our Node app, which is 0.1. But if you see now, we have also a hidden Docker image, which is the node, which is the dependencies, which means that we downloaded Node without asking him explicitly. We asked him in the dependencies, which is in the Docker file. So let's move now. Now let's run our first application. Once we compiled everything, we will tell him, okay, Docker, now that you compiled everything, we want you, let's use here Manit. We are saying, okay, Docker, now run on port 4,000 on 18. Now, what's the difference between this one and this one? This one belongs to Docker. This one belongs to our physical machine. So which means that as we cannot use the port 18, we are not allowed to use it because it's a reserved port. We are redirecting our port here. We are saying run it on port 4000 on our machine, but on the Docker, we want it to run on port 18 because we expose it on the Docker file. Now, what he will run my app. We name it my app. Now, what is my app? It is the Node app 0.1. Here, what we are doing, we are using the continuous delivery, which means that we are deploying our application. And as I said earlier, there is difference between continuous deploying and a delivery, and deploying, because we delivered our application here, but we want to deploy it. So we are not making the strategy green, blue, green, or canary. We just want to ship it to everyone. Now, once we run it now, what happens? It says, perfect, server running at HTTP is exposing all the interfaces on 18. Now our application is running. So we come here and we use curl. Now, if as we cannot look, our shell is blocked, we can open another shell. You just come here, and you have plus out cloud shell session. You just wait, and you have another shell. It's like tabs. So if we run curl, it says hello world. Why? Because our application is already running. So in case you don't know what is a curl, it's a browser but on console. You have curl and you have wget, because sometimes you don't need to see what's going on. You just need to go to the file. I give you an example. You have, for example, this link, http and test.com, and then you have file.zip. As you don't need to check about the zip, you just want to download it. You don't need to open the browser. What you need is just to do wget, and then it will download it. It works on Linux. You have wget, and you have the library which is called curl. And as we don't want to open a new tab, we just want to check if it works or not. If we stop it here, you're going to see what happens if we hit the Control-C, which is called the keyboard interrupt. And if we come back here and we do the curl, you see, now it's failed to connect. Now, there is something important. There is a difference between how it works and how we are calling it. Check this. I will rerun it now. And what he says, and be able to reuse. I should not. So docker ps yes.a. I hate this when it happens. So I should rebuild. Now let's build this and let's run again. You have to remove that container to be able. Oh, I will remove it in a few seconds because that's the next step. So check here. When we ran it earlier, we ran it on, it says it's running on port 18. So if we go a little bit here and where, I'm sorry for this. It seems that it got, where is that? Okay. Ugh, where is it? Anyway, when we run it, it said that we are running it on port 18. Remember that. But when we use the CURL, we didn't ping. It's kind of ping. I don't know if you know the command ping. So when we do ping 888, we are checking if we have a connection or not. So when we ping, when we checked our server, we checked about 4,000. So because 4,000 is the real machine, not the Docker machine. Once we get to the 4,000, we are redirecting the 4,000 to port 18. So CURL failed to connect to localhost port 14. Did you run the application? It must be in second tab. What says in the first tab? Because the first tab, we run it. We could run it on a background using the no-hub, but that's out of our scope. We just wanted to check what happens there. So, I mean, what's going on? Oh yeah, of course, because the port is no longer used. So you can check, for example, using nmap. Nmap is a tool to check. So you can install it. Sudo apt install nmap. Nmap is a tool to scan the ports that are getting used. So if it's opened or it's closed, which means that when you are using, I can install it now. If you are using the application, this port is closed. That's why you cannot run two applications on the same port. To do that, we are going to see that in next session. It's about load balancer. So it's just as like we say in French, culture générale. It's a general culture. It's to say that it's an information you have to know. So as we stop it, the application, of course, the port will not be responding. So now let's stop how we should stop it, because we should stop it with this way, not using the Control C. See, now when it was working here, running here, we have to stop it in the safe way using the Docker stop. Now, like this, it says that it got stopped. Everything is perfect. We stopped our Docker. Now, if we do the Docker PS, nothing. Now, we need our, well, let's go back to SRE. As I told you, the site reliability engineering, which is the key feature of Google, the Googlers, they have a philosophy. We said there is the DevOps and there is the philosophy about the SRE. If you see that the base is the monitoring, we need to know what's going on our application. That's why on Docker, when we run our application here, let's rerun it again, and we do ps. See, now it runs because even Control C didn't stop it for real. We need to stop it safely, or we do the ps and then we get the process ID and then we use the kill command or pkill, process kill. Now, if we come here and we do Docker logs, what we need, as you see, notice the container output Docker. Yes, we have the name. or we can use the ID. So this ID here, we can come here. Now, everyone has his own ID. Don't copy and paste the same ID. So for myself, it's this one. So if I paste it and say Docker logs, and then I passed the ID, I remove the trailing dash, it says that the server is running here. If I give him another ID, for example, this one becomes 3, it says no such container. So we need to rerun it again. So let's stop it first. Once we stop our container, we remove it. I pasted the decoder stop and docker rm the first cloud shell, but nothing happened. Of course, nothing happens. It shows you. It should show you this, because what we did, we didn't only stop my app, but we removed it. Look, if you check the rm command is from Linux, which means remove. Not only we stopped it, but we used the command end to say, once you stop it, we want you to remove it. So you should have something like this. My app, my app. Maybe it's not running. How about the first tab? What does it show in the first tab? Is it still running on the first tab? No, 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 you don't need. You don't need to. Just keep it. Because you are sharing the same Linux shell. The tab is just here so you can type another command. Well, let's do this. If I do ps everything full, now if I do grep docker, what gives you this command? Let's zoom on it. Let's do it in a Linux way. Is the Docker running? No, that's okay. That's okay. Nothing? That's weird. The command ps, it should give something. Well, let's try something. Echo hello. Let's see if the shell is working. Can you type this echo hello? Let's zoom on it. You should have something like this. Hello. Unless the shell don't work. Ah, perfect. Let's move on. So everything is going. So Amy and Ami, can we move? Perfect. Perfect. I have two yeses. So let's go again. Now, what we are going to do, as we said, we are doing a continuous delivery and continuous integration. So imagine that we want to change something on our code. So imagine we want to let's stop first our Docker. We already did. So let's see where we are. So you see pwd, we are already in test. Pwd to say process working directory. This is like where we are. It's kind of GPS. So as we are already in test, we don't need to type test again. We just need to go to app.js. So before we're gonna edit this, we have two ways. We have the old school way using directly the console, or we have this tool, code editor beta. If you come here, in the Cloud Shell, it's gone. So it will rerun now the Cloud Shell. I will show you. Just 1 second. It's still loading. We have two ways how to change our code. We have the old school from the console using Nano or VI or what editor you want. Or we can use change it using a visual editor where we can use the copy, paste, and all the tools we need. So if we come here, let's run a new Cloud Shell. You come to the pencil icon, this one here. You will have launch code editor. You just hit this and wait. It will run a new tab. And here I do reconnect because when I opened the first shell, it got disconnected the second one. And here, if I zoom here, you can see that I am using now a visual editor as I am using the mouse. So what we need to do, we just need to click on the app.js and we will have a visual editor here. So what we do, we just change a small chunk of word here. Instead of hello world, we say, hi, I am live, or whatever it says here. For example, here it says, welcome to cloud. We just want to change the string. Our objective in a real world, we don't just change this. We change a lot of things. What do I write in the container? Yeah, the container ID, you need to write what you got in PS here. When we were running it, if you come here, what we did the Docker PS here. The Docker PS, once we get the ID, we are going to have the logs about this Docker image. So because in production you will run a lot of Dockers. So we need to check only one Docker, not all of them. And as the name is ambiguous, we can run a lot of Dockers. We could have a lot of names. It's preferable to use the ID as the ID is unique. Did you run the visual editor? Amy, is everything right? Perfect. Now, once we change the hello world to hey, hi, I am live, we just need to do save, and it's gonna save. No, you don't need to. So what we do, you just use pwd. pwd, and once we are in test, we don't need to use the cd because we don't want to get to another folder because there is no other folder called test. We just need to hit this launch code editor. This is to avoid using the console and using those complicated editors. So we just need to use a visual editor because we have the habit to use the visual editor unless you want to use SSH. By the way, right now we are using SSH because it's just a browser. So we are sending and getting back our commands using some kind of SSH. So what is going on now? It's not happening on my machine. It's happening on the cloud. So is everything fine? Perfect. Now we just need to change hi, I'm live. You come here where there is hello world, you just change the name you want. I just put hi, I'm live, and then you come to file and do save. It's like a normal editor. Now, if we come back to the tutorial, we're gonna build it now. But if you see, our build has changed. Earlier, our build was called 0.1. Now it's called 0.2, which means that we are using the continuous integration. So we need to name our application with versions. This is to avoid mistakes. So if we validate now, Docker would build a new application. Instead of saying hello world, now he is going to build it with hi, I'm live. Now, if we, because we still have 13 minutes, we are good. Now, once it got run, let's rerun it again like we did earlier, but this time not using app 1, but using app 02. And here we go. We repeat the same steps, curl, localhost. Now what it says, hi, I'm live, because now our application changed. So imagine it's an HTML and or it's a CSS and you want to change the color from red to orange and so on. You need to name your version. You need to say 0.1, 0.2, and so on. But you need to have someone who will do the commit, because the continuous integration, how it works. Even if I clone this repo, that's called the repo. and I bring it to my own account and I try to pull an update, it will not get validated. It needs a review. And once someone review it, it will make it to the real branch. And that's what needs to do here. We need to name the branching, but that's out of our scope. That's why I advise you to check about continuous integration and delivery. That's something special. Now, let's go back here and we need to do the debug. The debug is exactly where you asked the question. It's about how we are going to check the ID. Once we get the ID, we need, so if I do docker ps, we have this ID, we copy it, everyone will have its own ID. And then what we do is docker logs -f ID, and then we have the server running here. So that's just what we want. Now, let's have some magic. We open here and let's do this command. We change the container ID, I'm sorry. So I need to bring this ID, not this one. I need to do this. If you check automatically, Google will pass. And if I do this, if I say pwd, if you see, that's the magic of Docker. Right now, I just entered, look, I have the diez, which is called the hashtag or whatever you want to call it. Earlier, I was in home. Now, I just changed it. Now, what that means? It means, okay, Docker, now execute a shell on this container interactively. That's what means IT, which means that now I can run any command on this container, not on this shell. Now I just entered to the container. Now I'm inside. If I do pwd and I do ls, now I'm inside the container. I'm not outside of it. So if you run, for example, now if I do exit, now if you do docker exec and you do here CentOS, no such container. If I do docker run, sorry, and wait, what I just did, I just changed the shell from Debian to CentOS. If I do pwd and I do ls, I have a fully functional CentOS operating system. So here is the command. You just need to do docker run it CentOS bash. But for our purpose, we did docker exec it. We entered to the container we just created. Now, if we do inspect now, inspect is kind of, we keep our ID. I come here and then I do docker inspect. Inspect. I give him the ID. No such, I just removed some kind of word. Oh, I forgot the 6. I removed the 6. So if I do docker inspect, if you see here, we have all the information about our Docker. Not only the log, but all the information we need. Its IP address and all the information we're going to use. So we just need docker inspect and everything works with the ID. And the ID, remember, we retrieve it using docker ps. So every time we need to do something, we need to know which one we need to study. So once we get the ID, we can use Docker logs or Docker inspect. It depends on what we want. So now that finished, we have still 6 minutes, but we are right there. We need to publish our Docker because we need to share it with someone. So what we need, we just hit this. Let's come here. We get our ID. So let's move this here. Now we have this ID. We need to use this ID to upload our project. So here is the syntax. We need the host name slash project ID slash image dash tag, which means the version or whatever you want. What we used earlier is 0.1. The image is the name of the image. The project ID is the name that we need to use, and the host name is always gcr.io. This gcr.io is for Google Cloud. We are uploading our project to Google Cloud, but if you have your own repository, you have to change this. So now let's copy this. Let's come here. Project ID. We're gonna remove this. We're gonna have this. We copy it. We paste it. And we just publish it our with. Well, about the name, don't worry about the name. The name, you can use your own name. So why the lab choose this name? To avoid having the same name. In case you will upload with a name that you know, you can have the problem. Now, it's not yet uploaded. We need to upload it. It's exactly what you do with git add dot, and then when you do git push and so on. For people who use git, this they will feel at home. Now what we need to do this, and earlier we just tag it. We make a tag, we name it with a tag because we are using, remember, we are using continuous delivery. So if I bring here and I paste, if I validate, now my project is getting uploaded to GCR, which means that I can share it with my teammate and so on. And to find it, I leave it up, getting uploaded like this. I'm pushing my code base to the repository. So what I need, I just need to come here, I reduce that, and I just retrieve it here. So where it is, it just in tools, container registry. So let's get where it is, container registry. Did you find it with me? Tools, container registry. Now imagine that you are like me, tired at the end of the day, you don't find it. You just come here and you write container registry. Here you are. You can have it instantly. You don't need to search it here. Right now, it didn't got uploaded yet. I need to wait until it finishes here. It's still uploading. And as you can see, as I told you, it's kind of SSH. I'm not using my connection because it's impossible to have this kind of bandwidth. I'm using the Google connection. So right now, everything is happening on my rented machine on the cloud. It's not happening on my machine. Everything is on the cloud machine. The browser is just here to show me what's going on. This is for people who use the SSH. This is like PuTTY, the software called PuTTY. I'm waiting. I hope I'm in time. 2 minutes. I will be exactly with this. We should be exactly with time. The goal is not finish the lab because you can have it again on your side. The goal is to explain you what's going on. And by the way, all the videos are recorded. You can check them whenever you want, wherever you want. They are on the channel. You subscribe, you will have them. You can see the session before, and the session that comes after. There are many things to learn. There are machine learning, there is cloud, there is everything, and it's in 3 languages: French, English, and Arabic. So you got served. I'm still waiting. As you can see, it took time because I have so many dependencies. So that's why some developers, where can I learn the basics? The basics, that's what we are doing. We are, there will be a session, I guess, about Google Cloud Platform. But I advise you to check about the GDG because our session is limited in time. Once those 3 hours, there will be maybe other sessions, of course, but the best way is to continue what comes after. And what comes after is the GDG. The GDG, they are in a real person. You can meet them, you can ask them, you can come to us. If you are in Algeria, you are welcome. There are many GDGs in Algeria. If you are in USA, there are GDGs, and the access is for free. You just bring your laptop, and there will be a one-on-one sessions. So don't worry about this. We are here to share the knowledge. That's the objective of uh, Google developer groups. We are here to help the community. So now, if I come back here and I refresh, I find my Node app that I can share with my roommates, sorry, with my colleagues, and they will see everything what I did. And check, that's the ID of the commit. For people who knows what is the commit and git, you can know what is that. Now, if I come back here, oh, the lab just finished it. No, it finished it with 0, but don't worry, you can do it again. Don't worry about this, but I think you cannot do it for 3 times. You have to do it. Now that you do it, I guess it's the same for you. Yeah, I got 1 hour. I talked too much. I forgot. Yeah, now the session will disconnect because now if I refresh, it gives me a few minutes and then they will disconnect me from the GCP because your time on GCP is tied to your time from the lab. So be careful. Don't worry about this. We can do it again and again. But our objective, let's do another one, but this one, we're going to do it in 1 hour. We are not going to lose this time. We're going to beat the time. Are you ready? I told you, today I'm a real left-hand guy. I'm messy. Now, are you ready to go to orchestrating with Kubernetes? We saw what is Docker. Now it's time to see what is Kubernetes. And check that long. Don't worry about this because this lab is really good because it will explain what is a service, what is a pod, and so on. Are you ready? You are still with me for 1 hour. Don't go. Now let's do it. I want you to have this and open it right here. Google Kubernetes Engine. Are you there? I wait you until you get all of you here to not lose time. I don't want to start lab unless I fix the page. By the way, if you like this session, there will be other sessions in different languages. And don't forget to check your local GDG group, because that's how it works. And the best thing, oh, okay, I mean, have a nice day. Thank you. I hope you enjoyed it. So, about the GDG, you are going to have the same session, that it will stay for 1 day or two, which means that you will have enough time, you will have one person with you will have all the group with you will share a lot of things. I really advise you to check about the GDG on your community. You have the link, you just check. If there is no, yeah, thank you, I mean, if there is no GDG near your home or near your town, you can ask Google to create one. You just bring the developers, make a community, share the knowledge, as we are doing right here. Let's go back to our Kubernetes engine. Amy, are you there? Amy, did you start the lab? Wait. You started before me. Let's do it. Okay, let's close everything here and open a new incognito tab and give me 2 minutes. Yeah, did you start the new? We wait here. Exactly what we did earlier. Those steps are always repeating. We copy and we come to the private browsing. We passed and we just copy the link, copy the ID. I will just create a new window and then I will wait for you. And then here, accept and done. No problem. And I will stop when it shows the GCP interface. Okay, here I agree. I don't need to check this. And here we are. I'm waiting for you. I just stop here and I wait for you to come with me. Amy, when you are ready. Perfect. Now, we just activate the Cloud Shell, exactly what we did earlier. Here, start Cloud Shell. Behind this, well, I want to show you something. So if I come here, as you can see, the products are grouped like that. If you see, we have groups: tools, stack driver, networking and storage, compute, and those ones. So if you want to monitoring, you need to use a tool called stack driver. That's out of our scope, but if you need a tool, it's a good tool to make the monitoring. And what it do what we call the black box monitoring and the white box monitoring, inside and outside. If you use the tool called how to call that? Forgot. Nagios, yeah, Nagios, then you are doing a black box. There are many other tools that do white box, which are the HTTP request and see what is outside. If you need something inside, there is Nagios, but if you need something about the cloud, you have Stack Driver, just so you know, because we said that it's the base of SRE. Alan, so, sorry, I start mixing French and English. Check this: App Engine, Compute Engine, Kubernetes Engine, Cloud Function. App Engine is what we called earlier PaaS, Platform as a Service. You pay as you go. You have the Compute Engine. This is what we call infrastructure as a service. You can create a machine on the cloud. And then you have the Kubernetes engine that you can create your own Kubernetes engine, which means that that's kind of new service, but related to Dockers and Kubernetes. You can install this on Compute Engine, but you have to handle everything by yourself. But if you are using Docker and Kubernetes, you have the Kubernetes engine. So we can start now using the Cloud Shell, and we will type the commands. First command, we are going to create a new, we are going to first configure our zone. So I just explained this fast. We said that the cloud, it doesn't have boundaries, it doesn't have political borders, it just moves. So when we use this, we are choosing the closest computer to our location. So you can change this with whatever values you have. So you just come here and type GCP zones. And then if you are in Europe, if you are in Asia, you have to check the one that is closest to you. So you have all of them. You have Europe, you have US. So if you live in London, for example, you choose Europe West 2. Just because when you ping, you have this latency. So the closest you are, because you have the network, so it's better to give your product near your customers. Don't oblige them to go to the other side of the world. That's it. But when it comes to labs where you see those scoring, you have to respect exactly what they ask. You cannot configure a zone, or it will consider that you didn't do what they need. Now, once we created that, configured the zone, let's create container. Wait a little bit. It takes time because it is configuring and creating a new. We wait. Oops, sorry. Now, before it finish, let's talk about Git. As I told you, Git is exactly this. So if we want to download our code, we just use the command git clone. And it's exactly what they did here, which means that they come here. So if we come to this, we remove the git and we come here. Here is our source code. You can read it here. You can check what it has. It's like just folders with script shell, Nginx, deployment, configuration about Nginx. So if you are a web developer, you know what is Nginx. Nginx, it's a reverse proxy, and it's a load balancer, and it's a web server. It do all of this. So what is a load balancer? So imagine you have a machine A and a machine B. So let's talk with our example. We have a Docker 1, we have a Docker 2, and we want the traffic to go to Docker 1 and Docker 2. If Docker 1 can handle the traffic, we send the traffic to the Docker 2. We use this with what we call load balancer. We are splitting our traffic to avoid the system to stop. Yeah, Nginx is just a server. It's like Apache. It's like, generally we start developing website using WAMP. WAMP to say Windows, Apache, MySQL, and PHP. So if you want to create a website, you have already Apache that comes with WAMP. But if you want to change the stack, you just remove Apache and you replace it with Nginx. But you have to check about the plugins, about the modules, how you are going to configure PHP to communicate with your web server, which is Nginx. Or you can use what is now, which is Node.js. Node.js is already a web server, and if you want something better, you use Express.js, which simplifies. All of this is out of the scope. So our objective in this course is how to ship your website, how to upload it, how to use Docker to ship your Express application with continuous integration and continuous delivery. And that's what we call orchestration. Because in orchestrating, imagine one pod or one Docker fails, you need to know which one failed, and you need to know how you are going to handle this. You are welcome. So let's go back. I hope. Okay. Now we have our machine, which uses GKE, which is the Google, Kubernetes engine. This is the version. We used this type of machine, and we have 3 nodes. A node is a machine. Now, let's copy this. We retrieve an application that is ready. So our objective is not write the application from scratch. We just need to understand how Kubernetes works. So we are just copying and pasting here. We do ls, and we have exactly what we just see here. We have cleanup, deployment, Nginx, pods, service, and TLS. So if we come back here, I think I closed it. Oops. Sorry. So let's go back here. Let's copy this. Let's paste it here. We have exactly the same. We have cleanup, TLS, service, pods, Nginx, and deployment. That's exactly what we just downloaded right here. Let's go back to this. Now we create our deployment configuration. The easiest way to get started Kubernetes is using this command, kubecontrol. Kubecontrol is already installed when you use the Cloud Shell. You don't need to install it, but if you have an offline machine with Linux, you have to install Kubernetes. And we just name it Nginx. We are using an image which is Nginx, which has the version 1.10.0. Now, if we check our pods, now what is the pod? Let's come here. A pod is just our Dockers. So when we assemble our Dockers, we get what is called a pod. A pod, as we hear, we wanted to check which pods are running. And he says, okay, you are running this pod. Now let's come back here and we want to expose it outside of Kubernetes. So we want to access to it using the port 18. No, that's okay, that's okay. Now, so which command are you, did you create the machine or you have to recreate it from scratch? Is everything okay, Amy? No problem. We will continue and you can find all the steps recorded as the video will be available later. Yeah. You have to stop the, you have to do end lab because uh, when you got disconnected and refresh, it could be, if you check here, you could using an old session. Sorry, not here. Maybe when you started the new lab. Well, if I come here, no, don't worry about the warnings. The warning is just about the version. It's like about the deprecation and so on. So even if you got those kind of warning, that's fine. Yeah, because you are still using your old session, because even if you got disconnected, but your session is still on the cloud, which means that if you reconnect, you just need to hit F5. If you try to hit F5 on the console, I guess you can get the session continue. Now what we are doing here, we are just exposing our application, and we say that the type is a load balancer. As I just said, a load balancer is used to handle the traffic, and we are doing service. Now we talked about the pods. Let's talk about the service. Here we talked about the pods. Yeah, you need to disconnect from the old tab. Can you follow with me? And then once this video will be recorded, you can start the lab as you have the free month. Is it okay? Now, if we go back to our presentation and check what is Kubernetes, we have a replication. What is a replication? A replication is our application but duplicated. That's what is called the replication. When you use database and you use two versions, that's called replicating the database. Now, the service is what exposes your application or your pod. We have what is called a pod. This is the pod. This is a pod. Now, a pod is what we used earlier using Docker. Now, we have the pods. So if a pod fails, we need to know which one failed. And to access to those pods, we need a service. A service, once we access to the service, here comes Nginx to let us go here or here. And we have the volume, because when you save something on the Docker, it's not persistent. We need to get them persistent. That's exactly what is Kubernetes. We have the concept of the pod, we have the concept of the service, and we have the concept of the volume. So the service is the IP address, the volume is the persistent partition, not database, it's just a partition, and we have the pods, which are the application themselves. So if we come back to this, that's exactly what is explained here. The volume, sorry, the pods, and the service, which is the IP address, and the volume. Where is the volume? Okay, it's not there, but don't worry, the volume, because it's when you really need to persist something. So let's go back here, and we stop it in service. Now, what we need when we did kube control get services is to get our IP address. So if we copy the external IP here and we paste it here, see, we have Nginx. We just created our first web server. Yeah, that's okay, Amy. You can rewatch the replay because it's recorded, so no worry. So we continue here, we check our progress, that's fine. We are in time. Now, the pods, we need to create the pod. Now, if we do this, as you can see, the cat command is to show the content of a text file. Since YAML is just a text file with indentation, we have kind, API version, metadata, spec, and so on. So we need to use this YAML file to create our pod. So what we did is that's exactly what we do all the time with Kubernetes. We need configuration files, we use kube control, and then we use everything relies here. So you need to understand the configuration files. So when we do this, once we created our pods, we need to retrieve them. We just created them, and then we need to retrieve them. See, now those are our pods running. That's just an extension about what we did earlier with Docker. Now, describe, it's a command that talks about herself. It just tells Kubernetes to give much more information about our pods and its detailed information. Now let's continue. Now we want to interact with our pods. So as you can see now, we are forwarding our port from 10,018 to 18. It's exactly what we said earlier. We have two ports. We have the machine port and we have the Docker port. Here we have the machine port and we have the pod port. So if we come here and recheck our slide, this machine is the physical machine. Those are our pods, which means that this physical machine, we are using the 10,018 port, and every pod we are using a special port. That's what is called port forwarding. So now, if we open a second terminal, sorry, here, so we need, it's exactly what we need earlier using Docker. This console is already taken by this command. So we need to come here and cure. And you see that we got a message. That means that there is a response. Check that we called using the machine port, not the pod port, because we are exposing the machine port. Now, let's try a URL that is secured. We suppose we want to check this URL. It says no. Now, let's try another URL. Now, in this, the password is password. You can guess it. And password, sorry. Yeah, I'm on Linux. I forgot that I cannot see what's going on for security reason. So now this URL gave me, but secure, it didn't give me. So I guess that you already know something about HTTP language, oh, not language, verbs. So if we now try it, still nothing. We said authorization bearer, the token. What is the token now? The token is this. Let's copy this. Now let's paste this. Oh, it got frozen. Sorry. So, okay. We need the log. I don't know what's going on, why it got frozen. Okay, everything works fine. Let's see more logs. Now, we have to open a third terminal. And don't worry, we are still on the same Linux. Those are just tabs, exactly what we do on Chrome. They are just tabs that are interacting using commands. So earlier, when we used Docker, I showed you a command that allowed us to use bash inside Docker when we used CentOS. That's the same thing here. But here we are using TTY. TTY is just teletype, which is, for people who come from Linux, is what we are typing here. It's called TTY, and we are TTY 1 until 7 on Ubuntu. So here we are inside the pod. So that's the way how we are going to interact inside the pod. Now, let's try to ping. What's going on? Why we tried this? This is to tell you if we have a connection inside our pod, which is okay. That's why we use the ping. So the ping is the command that allowed us to check if we have the connection or not. So let's exit. So here, let's stop this, and I want to try something that didn't work earlier. So let's have this. Sorry. So earlier when we tried to access to this, we could not. Now let's add something on. We need to save the token here. So password. Now let's copy this like this, and let's do token equal. Sorry. Now let's try again with a bearer like that, and see, now it worked. Earlier, when we tried to access the secure, we could not. Authorization failed. But now you use the special token, which is this, to access a special link. And now it works. When we use token, we are using this. So we are using a special verb, and we got authorized. So that works. We can move on, because I hate letting things that didn't work. It must work. So let's go back here. A service, as I told you, is what we can imagine right now as an IP address. So if you want to expose your application, you use what is called service. A pod needs a service to be accessible outside. So let's copy this. Let's cd tilde, which is home, to the folder Kubernetes, which means that we are here. So yeah, we are inside Kubernetes here. So once we are here, we want, sorry, we want to check secure monolithic YAML, which means that every time we use something on Kubernetes, remember, it's all about the YAML file. And by the way, never mix tabulation with spaces. Use spaces, don't use tabulation. I guess there is a command on Linux which is called expand. Expand, it converts the, sorry, so if you do man expand, it converts the tabs to spaces. So always use spaces, don't use tabs. I guess if you are from Python, you know that. Never mix between them. So let's run our new configuration to create new pods. So we just recreated new pods, and now it's time to create our service. We are going to expose our application on HTTPS. That's why you see 443. But you are always forwarding the port. Remember that. And remember that we are just using the names because earlier we created an application called monolith. So don't mix the names. Yeah, thank you. Sorry, I didn't follow the comments. Thank you, Amy. So now let's create our service. And now our application will be exposed to the internet. We are at 3. Now let's create our firewall rules with the command gcloud compute firewall rules, because right now we need to open some ports. As we are using a virtual machine, you have to remember you are like in a real machine. You need to handle the incoming and outgoing traffic, which is called, wait, okay, we just created, which is called ingress and egress. So you can Google it, ingress versus egress. That's the words we use in the cloud. The egress and the ingress. The ingress incoming, egress outgoing, for people coming from routers and firewalls. So let's check the progress. It seems that it works good. Now we need to check about our machines, what we created. As you can see now, we have 3 accessible IP addresses from outside. So if we just copy this and come here, this one doesn't have a web server. If we come here and paste here, same. What I try to say is not because you have an IP address, that means that you have a web server installed on it. So remember that. So this is just to expose your machine on to internet. That doesn't mean that you have this. So to check if you have the machine running, you just ping 226.27 and 120. And remember, there are some practice that even the ping could not work. You can check this about hardening the OS. Even the ping will return nothing. So just ping. Now let's check the monolithic. Where is the monolithic? So where is it? Once, yeah, when we copy this address and then we paste it. Why it didn't work? Because we are not running it on the default port, which is 18. Because when we type an address, this is like we are doing here, like this. So as we are running on 31,000, let's try this. Let's check about the other IP addresses. Nothing. Why? See, there is a timeout, which means that there is something wrong. And here is the explanation. You have everything on the quick lab. That's why I told you this lab is wonderful, because it's not only copy and paste. It only describes everything what's going on. So if you do this command, come here, we are going to do the debug. There is no external address. Now, if we do this, as you can see, I only have an internal address. I don't have an external address. That's why it's not available from here. See? So always when we work with pods, we like to give them tags or labels. So we need to label them so we can hit them directly to the when we use the configuration. So it's not enabled yet. Let's go through this. Okay, it worked. That worked. Now let's come back here so we can get our endpoint. By the way, the endpoint, for people who don't know this, it's when you use the API, the endpoint is the IP address where you are landing. So when you copy this, let's now get IP address. Now let's change this. So 35, 226, 27, and 120. And we have our application. Now it works because we exposed our application to the public. Check my progress. Everything worked fine. Now we need to deploy. Now, the deployment, as I told you, there are many strategies about the deployment. We have the canary deployment, we have the blue-green, and so on. So let's check about the configuration file. So let's read a little bit. So we have deployment, which application, which image we need to deploy. We have which port we are going to use, and we have some delays. We are going to control everything. When we deploy our application, we are going to tell Kubernetes maybe there is something wrong because he will wait. And once he waits, he will wait a certain time. So if there is something wrong, he will know what to do. That's why we are using the delay and so on, because we don't want to wait forever. Remember, it's an orchestra. So his job is to manage those kind of delays. We are just affecting those kind of configuration. Don't worry about this. So always remember, everything is about the YAML file. If you do the YAML file, you are doing everything. Now, I just created my configuration. Now, let's retrieve the service. It's pending. It didn't give me yet. So let's repeat. Not yet. Let's try this watch. gdn-n. So watch is a invalid argument. What's going on? Yeah, sorry. Watch n. Let's say every 1 second. So the command watch, what it does, is just repeating the same Linux command every time until every 1 second. Why I did that? So to check exactly when Kubernetes will give me my external IP, which is this. Now let's quit and let's cure my IP address, HTTP, and IP address, which port we are using. Yeah, HTTPS, sorry, because earlier we used 443. Now, why it gets the answer? There is no response. What's going on? Yeah, failed to connect. Why it's going on? Let's check again. Without, well, my IP address is this one. Is it the same? 35.226.167.147. So cool. Okay. HTTPS because it says that I'm using 443, and why it says connection. I must have missed something. Oh, I must have missed something. So let's redo the service. Yeah, yeah. It already exists. So why it don't give me what I want? Get service. Yeah, it should work. Why it doesn't work? Let's go back to the top and let's repeat this. This one is the internal address because always you have internal address, because if we come back here, if you see here, they are using internal address, but the service must expose it to the outside, which means that our IP addresses, our external IP addresses. I must missed something. That's a big mess. That's okay. Anyway, I must have missed something. I'm sorry about this. But let's resume this one time for all. Kubernetes, you have to create Dockers. Once you create Dockers, you manage them using Kubernetes. When you manage them using Kubernetes, you are exposing them to IP address using what is called service. And every application, we call them pod. And the replication is when this one hangs or fails, I must find a way to make it to this one using a load balancer. And that's exactly what we do in application, what we called DevOps. So when you know how to use Kubernetes and then split your application on microservices, you are doing the DevOps. And that the DevOps is the way how it works now. So you need to rewatch, to rewrite your application so you can split it on microservices and then use them inside Dockers and then make Kubernetes handle them. That's the way how we are using application in 2019. I hope you enjoyed that. I'm sorry for messing up. I hope you understood something about what is a container, what is SRE, what is Docker, what is Kubernetes. I was with you since 5 here in Algeria time. Thank you very much. I hope you enjoyed that. See you next time.